Now define f from R to R by f of x equal to tan x. Now this will not a function. Why it is not a function? Because what is tan pi by 2? Tan pi by 2 is not defined. Tan pi by 2 is not defined means there is no image for pi by 2. If any element of the first set has no image, then it will not become a function. Therefore it is not a function. Not only for pi by 2, there is no image for 3 pi by 2, that is tan 3 pi by 2 is not defined, tan 5 pi by 2 is not defined, tan 7 pi by 2 is not defined, and so on. And these elements are not having image. That is why if you define a function f from a to r by f of x equal to tan x, where a is equal to r minus 2n plus 1 pi by 2, because these are all odd numbers, 1, 3, 5, 7, minus 1, minus 3, etc. All are odd integers. Odd integers can be written in general by 2n plus 1. Therefore, you have to remove all the odd multiples of pi by 2. How to remove the element? You have to take the set R minus these elements, odd multiples of pi by 2. Where n is an integer, you will get odd multiple of pi by 2. And this set, if you take it as a domain, then it will become a function. F of x equal to tan x will become a function. And after that, you can draw the graph of the function, and the graph of the tan function will be like this. Tan 0 is 0, tan pi by 2 is not defined, tan 30 is equal to 1 by root 3, that is tan pi by 4 is equal to 1, and the graph of the tan function will be like this. And this function is not 1 1. It is possible to verify whether the function is 1 1 or not on 1 1 by geometrically, that is called horizontal line test. If any one horizontal line cuts the curve at two distinct points, definitely it is not 1 1. Here there are many horizontal lines which cuts the curve at distinct points. Here, if we draw the horizontal line, it cuts here, 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 here. For all these values of x, f of x is same. Therefore, for all these points or real numbers have the same image. Therefore, it is not 1 1 function. But the function is onto, and that's why to make it 1 1, we have to change the domain of the function. And now you take the domain of the function as minus pi by 2 to plus pi by 2. Here pi by 2 and minus pi by 2 are already eliminated in the A itself, and you take all the real number in between minus pi by 2 to plus pi by 2, excluding pi by 2 and minus pi by 2, because pi by 2 and minus pi by 2 is already not there in A. That's why excluding these two elements as the domain and set of real number as the range, the function will become 1 1 and onto. If the function is 1 1 and onto, it is invertible, and the domain of the function should be minus pi by 2 plus pi by 2, and range is r, and the function is tan x. Then this function is 1 1 and onto, and therefore it is invertible. And what is tan 0? Tan 0 is equal to 0. Therefore tan inverse 0 equal to 0. What is tan pi by 6? 1 by root 3. Therefore, tan inverse 1 by root 3 is equal to pi by 6. What is tan of minus pi by 4? Tan of minus pi by 4 is equal to minus 1. Tan of minus x equal to minus tan x, that is equal to minus 1. Minus tan pi by 4 equal to minus 1, and tan inverse of minus 1 equal to minus 4. Sorry, minus pi by 4. Thus, it is possible to find the tan inverse x for all x belongs to R. And tan inverse x is defined for all real numbers. And finally, we can define the tan inverse like this. Y is equal to tan inverse x if and only if tan y is equal to x, where x is any real number and y belongs to open interval minus pi by 2 comma pi by 2. And graph of the inverse trigonometry function, that is tan inverse x, is like this. Tan inverse 0 is equal to 0. Tan inverse 1 is equal to pi by 4. And as you increase, the value goes on increases, and it continues like this. And it is continuous, and it will not stop here, to continue like this. And similarly, tan inverse of minus 1 is equal to minus pi by 4. Tan inverse of minus root 3 is equal to minus pi by 3, and the value increases as it approaches 90 degree or pi by 2. That means if you draw a line at minus pi by 2, horizontal line at minus pi by 2, the curve will approach this line, but it will never cross this line and never touch this line, but it is approaching this line, and in this case this line is called as asymptote to this curve, that is y is equal to tan inverse x. Similarly, at x equal to pi by 2, if you draw a horizontal line and this line, and if you take the curve, this line will be asymptote to this curve. These are the two asymptotes to this curve, y is equal to tan inverse x. The asymptote means a line which touches this curve at infinity. That means it never touches. Just the curve approaches the line but never cut the line or cross the line, and such line are called asymptotes to this curve.